Hi everyone, in this video I would like to talk about the content across 11.1 to 11.7 as the exam style integrals are all mixed up where you need to quickly identify which technique to use for each integral. For instance, if you look at the questions that I have here, these are from mixed exercise. We need to use different technique for each separate integral here, and feel free to pause the video and if you would like to try and identify which technique to use for each integral, whereas I will spend the next couple of minutes review the integration in general across 11.1 to 11.3 ish, and then I will have my take on how to identify quickly the method to use for each question here. Right, so let's get started. We'll firstly have an overview of the integration, and I'll share you my take on how to decide what to do for each case, starting from the first 9 standard integrals from 11.1. If you take sin x, for instance, here, number 4, the integral of cos x with respect to x is sin x, because for the expressions in green, when you differentiate it will give you the expression within the integral. And in 11.2, we'll just take one step further, and all the standard integral is now in ax plus b form, where all the x originally is now in ax plus b. For example, the second one, the integral of e to the power of 4 minus 2x is just now written in x plus b form, and in order to solve it, you will just use the same standard result but divided by the coefficient of x, and hence divided by minus 2. However, there will be integrals starting from 11.2 onwards where you will be unlike these structures. For instance, if I just simply raise the power by 1, decrease the power from 2 to 1, etc. and etc., you could see that the results look so different. And another structure difference could be also simply by adding an x squared, or square root of x in front, and once again it will completely change the way that we will integrate it. And you could see for the first one, we will be using integration by parts, and for the third one, where we just raise both of the functions with a power of to 2, we'll use reverse chain rule or integration by substitution to solve it. So that's why here comes the format of how we could decide which technique to use for different case. So starting from the beginning, we would like to see if the integral that we are currently facing, if it is actually just a standard form, or if it is a standard form but it is just sugarcoat into ax plus b. If yes, then you could just end there. If no, then you could try and rewrite your expression using either partial fractions or trigonometry. And once you have done that, and the end product can be again solved with the standard integrals together with f of x plus b technique, then you could end just there. If the answer is still no, then you could consider using integration by parts, where there should be catered for integrals where there are 2 different class of functions within it. If yes, then finish. If no, then you could consider using reverse chain rule, which is in these 2 formats. Or if it is still not okay, then you need to really use integration by substitution. If the answer then is still no, then you need to revisit this tree and see if you have missed out something. So let's get started with our 9 integrals here. So starting from the top of the tree, we would like to see if these are just the fundamental results in 11.1, which is these ones. So there are no square root functions together with an x in the standard functions, so the answer is no. And for the second one, we could see that it is a power function and it is written in ax plus b form. Then yes, I could solve it using the first one, where I just need to add 1 to the power, divided by a new power, and then divided by the coefficient of x. But I'm not going to write the answers here. I'm just going to quickly run through how I decide. So for the third one, it's a fraction where it is a linear function in the denominator. Then yes, I could use the fundamental results. For the fourth one, that looks too complicated where to be true to use the fundamental results directly. So no, that one once again. This is not a fundamental results, although it looks really like the one written in the third one, but you need to be careful because the denominator is a quadratic function, which is not ax plus b, because whenever we say it is ax plus b, it is a quadratic form. Sorry, ax plus b is a linear form, whereas 16x squared plus ax minus 3 is a quadratic, so no. Okay, this one, the ones that we have products are all trigonometry functions, so no, this is not a fundamental result. So for that one, it's too complicated to fit these directly, so no. And finally, again, yes. So this is trigonometry, but this is not those reciprocal functions. So you cannot apply the fundamental results, these 9 ones. So let's board that forward to the next step. So here you could see we start off with 8 integrals, and there are 2 can already solve using ax plus b. And in generally speaking, later on, even in the exam style questions, there are actually at least 40% of the questions where after some manipulation, you could already use the standard results together with ax plus b technique to solve it. So anyway, the next approach, if you remember, will be with the remaining 6, we'll try to rewrite them, possibly using partial fraction or trigonometry, and directly apply again f of ax plus b. So for the first one, so it's 4 over 16x squared plus ax minus 3. So could we rewrite using possibly partial fractions or trigonometry? Yes, we could rewrite that using partial fraction. So let me just have a quick working out here. So the integral of 4 over 16x squared plus ax minus 3 will be 4 over 4x, sorry, 4x plus 3, sorry, 4x plus 3 and 4x minus 1. And then you could then decompose it into partial fractions. Yeah, and once you know the value for a and b, then you could directly integrate that using the technique f of ax plus b. So yes. So for the second integral, could we possibly rewrite using trigonometry? Yes, you could. Okay, so let me show you. However, let me just have let me just expose this. You can't really integrate that, unfortunately, using f of ax plus b. But yes, you could write using trigonometry, which is for both top and bottom. You could actually rewrite it something slightly different. So you could possibly rewrite the top as 2 lots of sine 2x, since sine 2x is 2 lots of sine x cos x. So you could rewrite 4 sine x cos x into 2 sine 2x. And the bottom, you could either change sine square of x using AS trigonometry, or you could actually change 4 minus 8 sine square of x immediately into 4 cos of 2x. Because cos of 2x, just in terms of sine squared, is 1 minus 2 sine square of x. Yeah, but so this is the manipulation that you could do, where you could rewrite this integral into that. However, that won't help you at all, because again, our standard interquartz does not have any fractions apart from 1 over x. So that's why you couldn't really carry on with this approach. So unfortunately, no. So I'll just leave it as no. So for the third one, yes, again, you could rewrite that using trigonometry. However, you cannot, the end product cannot be solved using f of x plus b format. I'll go through it in a minute. And for the next two, you could see that these has nothing to do with partial fraction or trigonometry. So you need to brought this forward to something else later on anyway. So for the last one, the integral of the product of cos x plus sin x and cos x minus sin x, you could integrate that after rewriting it slightly. So you could actually rewrite this into, you could firstly open up the brackets. There's just a difference of 2 squared. So that will be the integral of cos square x minus sin square of x. And the cos square x minus sin square of x is just a double angle formula, which is cos 2x. So yeah, that is the format that we see with the technique of f of x plus b. So you could directly integrate that. So yes. So let me just pause here for a minute. So you could see that there are questions, although you could rewrite with partial with trigonometry, it does not necessarily mean that you could solve it that way in the second stage. So in the second stage of the decision tree, we would like to manipulate the expression straight away, where you could integrate with the standard form. If not, you need to walk forward to the next stage. All right, so let me just, before we go any further, so let me just quickly explain why this integral, you can't really use f of x plus b. So if you change it into 1 minus cos square of x for sine squared, and you open up the brackets, which will be cos x minus cos cube of x, that will just give you sine x, and for the first one, but there's no answer, there's no direct easy answer for the integral of cos cube of x. So unfortunately, you need to use other techniques for that integral. So then we'll go to the next stage for the remaining 4 integrals, where you could see that at this stage, we would like to consider using integration by parts. So where there will be 2 different class of functions, and you will let u with this priority I late, where, sorry, no I for you guys. So late, where L stands for logarithm, algebra, trigonometry, and exponential functions. So you could see that integration by parts is really catered for 2 different class of functions. Whereas for the first one, so when you navigate through your different integrals, you could ask yourself the question at the first stage, at the third stage, and see if there are 2 different class of functions. So here for these 4, for the first one, they're all algebras, so you can't really use this efficiently. So you could say no. For the second one, they're both trigonometries. For the third one, again, they're all trigonometries. So whereas for the final one, x is algebra, and then ln x is logarithm. So yes, there are 2 different class of functions, and I could use integration by parts for this. We are left with 3 integrals, where you could either use reverse chain rule or integration by substitution to solve it. So in reverse chain rule, you could see that for there will be 2 different formats, where the component is either consists of f dash of x and f of x, whereas one is in fraction form and one is in product form. And the product form one will be to the power of n. So if I would like to use reverse chain rule, I would like to identify which one is f of x which is either going to be on the bottom, the entire bottom part, or within a power. So let's just recognize f of x for each form and see if the next part is going to be just f dash of x. So let me just highlight them. So f of x will be sine x for this one, because there's a square for sine x, and for the second part, so it is a fraction for the entire integral. So the f of x is 4 minus 8 sine square x, whereas for the third one, if we're going to fit into the reverse chain rule format, this is going to be 4x minus 1, because square root will change in the power of a half. So let's see. So for the first one, if we're just going to differentiate sine x, it will give me cos x, which is directly is identical to the function here. So that's why, yes, for the first one, we could use reverse chain rule. Whereas for the second one, so let's see if we differentiate the bottom and see if it will give us the same similar sort of functions of the one on top. So f of x is 4 minus 8 sine square of x. So f dash of x is minus 16 sine x cos x. So again, it's the same class of functions, which is a product of sine x cos x. So yes, you could use you could use the reverse chain rule for this integral. Whereas for the last one, if I differentiate 4x minus 1, I'll just get 4. And in this case, that does not fulfill the content that the format that we have. So we call that for reverse chain rule. It has to be either one of those, where the structure of the function has to be completely identical to the one that I didn't highlight. If it is different, then you can't use reverse chain rule. So here, the one that I didn't highlight it is x, whereas the one that I differentiate is 4. That means that does not fulfill the format here. So if that's the case, then I could not use reverse chain rule. So I'll just brought that forward. Now that left us just with the last integral, and there will be no choice but to use the integration by substitution, where usually we need to recall which expression we should let as u, and the usual ones will be within a power in the denominator, or within the function itself. So in this case, u will be 4x minus 1. And if you do not like to use reverse chain rule for now, that is actually fine. It's just that you need to sacrifice the pace of it. And actually, in fact, after integration by parts, for the integrals that you're left with, if you have deduced it correctly, all these integrals could be solved using integration by substitution. Whereas, yeah, once again, like we said, the u will be usually within the power or in the denominator. So that's why for the next two, u will be sine x, or u will be 4 minus 8 sine square of x, and then you could solve that integral. But once again, if you decide to bypass reverse chain rule, then you will need to sacrifice the pace. And you don't need to worry, there won't be questions where you could only solve by reverse chain rule, but not integration by substitution. Let me repeat that again. So there won't be any integrals where you could only solve with reverse chain rule, but not integration by substitution. Or actually, it is the other way around. So for the questions after these 3 steps, these intervals after integration by parts could all be solved using integration by substitution, but there will be exception, which is the first one, where you could not use reverse chain rule to solve it. So if you would like to deal with the problems at this moment just with integration by substitution, that is totally fine for me. So let's go back to the overview for those 8 integrals that we had in the first round. So you could see that we could use this decision tree to decide which technique to use for different questions. And obviously, at this moment, it will take up a lot of time. But if you do a lot of practices, then it will come slightly natural. So then I'll have a set 2 for you, and I would like you guys to also pause the video here to have a go and decide which technique to use for different integrals. So I'll give you a couple of seconds and I will get started, and feel free to pause it here. Right, so let's get started. Once again, the decision tree is starting from the basics, starting from the standard results, cooperate with f of x plus b. If that is not okay, then try to rewrite this expression with either partial fractions or trigonometry. And at this point, after the quick manipulation, it should still be easily solved with the fundamental results. If no, use integration by parts. If still no, then you can either use integration by substitution for all of it, or if you want it to be slightly quicker, there are some integrals after the first 3 layers can be solved using reverse chain rule very quickly. So let me show you here. So again, there are 7 integrals here, and let's see if there are integrals that match the format of the standard ones. So for the first one, there's none of it that is in a square root form with an x in front. The second one is a power function in the x plus b form. Good. That one, there's no fractions here apart from the third one, but it has to be a number on top. So no. So the only product of trigonometries in the standard form is reciprocal functions. So no, again, no, and no. So we're left with 6 integrals to work with, and there's only one that you could do the fundamental result. So with the remaining 6, we would like to sorry, let me just cancel that one. So for the remaining 6, let's see if we could rewrite it using either partial fractions. So let's have a look at all of these. So you could see that one, no, there's no trigonometry or fractions. So for that one, you cannot really factorize it because it's already in factorized form, and that one you can't really change it using partial fraction, and it's not in trigonometry. Nope. Similarly, the same case, so it's already factorized, and so you can't really change it into partial fraction. So that's as simply as you get. You can't really change it using partial fraction. So for that one, there's none you could do with that trigonometry, any identities that you could think of to change it. Same case, and in fact, all of these questions here, you can't really change it. So we'll move forward to the next stage, which is integration by parts, which is catered for 2 different class of functions. The first one, all algebra, and in fact, for the first 4, you could see they're all algebra, so you can't really use it. For that one, they're all trigonometry, you can't use it. All algebra, you can't use it. But for this one, you can, because this is 1 is algebra, 1 is trigonometry. So you could let u as x and v dash as sec square of x to carry on. So we call the priority of u is late. So I have both algebra and trigonometry for this question. So yes, you could use integration by parts. And now we're left with all these 6 integrals that looks really complicated, and they could all be solved using integration by substitution. And if you want it to be quicker, then you could use reverse chain rule. So let's start with the first one. If I would like to use integration by substitution, what should I let as u? So again, it will be within the square root 4 minus x. For the second one, oh, that one is non-existent. So for this one, again, u will be x squared plus 1. And for the third one, you will always try with the bottom or with the one inside the power bracket. So u is x plus 1 here. And then for the trigonometry one, so u will be within, again, the square root function. So sine x plus 1. And then that one, that will be u as 4 minus x squared. And yeah, so that's why you could solve all of this using integration by substitution. But if you want it to be quicker, you should be using reverse chain rule for some of it. And let's see which one we could actually use it. So again, for the reverse chain rule form, that will be that is consists of f dash of x and f of x. One is in fraction form, one is in power form. So let's have a look at the powers first. So for the power, f of x is 4 minus x and 4 minus x squared and sine x plus 1. And if I differentiate the ones in brown, I would like to ensure that the unhighlighted one will be f dash. So let's have a look. So in this case, f dash of x, when I differentiate 4 minus x, will be minus 1, which does not match. So I can't really use it. So for that question, you could only use reverse chain rule. Sorry, you could only use integration by substitution. And for the second one, the 3 cos x squared of sine x plus 1, if I differentiate that, f dash of x is cos x, that match with the unshaded part. So that's why you could use reverse chain rule, where you just add 1 to the power and then divide by a new power and divided by the derivative of what we just had. That is fine. Oops. Right, okay, so the third one, so if you differentiate 4 times square root of 4 minus x squared, so f dash of x is minus 2x. So they are both the same class of functions. They are algebra. They're just linear functions, so you could completely cancel them. So yes, you could solve it with reverse chain rule. So notice that these two, I just changed the power from 1 to 2, and the way to solve it is slightly different. So they can both be solved using reverse chain rule. However, for this question, you could only solve it with integration by substitution. So it's actually the same case for these two. Whereas if you make f of x as the expression inside the squared, when you differentiate them, 1 gives you 2x. That will cancels off with the x in front on top. Whereas if I differentiate just x plus 1, it will give me 1. That will not cancel out with the x. So I could not, once again, use reverse chain rule for that integral. So at these two, you could only use integration by substitution. So Out of these 5, there are 3 intervals that you could solve in a quicker way if you use reverse chain rule. Yeah. So finally, that's why if we just put them all together again, so the flow chart starts from the fundamental results all the way to integration by parts. After the first 3 layers, for the remaining candidates, you can always use integration by substitution. However, there are a couple that there will be cases where you could directly use reverse chain rule, where it will be quicker when you solve the integral. But at this moment, if you want to solve everything using integration by substitution, that is fine. It's just that you need to be careful of the time to spend on integration questions. So finally, there are 3 just standalone. We could just look at it starting from the chart and see where it takes. So let's say, for instance, if we do the integral of cot 2x, so which method should we use to solve it? So I'll give you a couple of seconds to think about it. Right, okay, so let's go over this. So is that in the standard result? So it's very tempting to do this, but unfortunately, there's no one standard result for cot 2x. So you can't say that the integral of cot 2x will be the integral of cosec squared 2x. That's not how it works. So the you can't reverse these results by saying that if I integrate tan x, that gives me just sec squared. That's not how it works. So I can't really use standard results. So can I rewrite this slightly? So let's see. For cot 2x, we could, is 1 over tan 2x, which is the reciprocal of tan. So that's why you could change it into cos 2x over sine 2x. And however, again, I cannot use the standard results here, and I couldn't use integration by parts. So that's why I could start by thinking about either integration by substitution or reverse chain rule. So here, if I use integration by substitution, what should I let as u? U will be sine 2x. Yes, so if you're not concerned about the pace, that's fine. You can let u as sine 2x and then solve the integral. Or for reverse chain rule reverse chain rule speaking, then you could see that it fulfills the format here. Oops, where are we? Yeah, so it will reverse. It will fulfill the format here, where you could see that if I call this as f of x, and when I differentiate that, it will give me 2 cos of 2x, and that will completely cancel out with the cos 2x on top, and that will also give me the answer. So you could use both reverse chain rule and integration by substitution for this question. So let's have a look at the second one. So once again, feel free to pause it here and have a go at yourself first. So for the integral of ln x, it's not in the standard form, and I cannot rewrite that with partial fraction. So I'll start by looking at integration by parts. And there are actually 2 different class of functions here. So one is ln x, another one is just 1 times. So I could use integration by parts for this question, where u is ln x, v dash is 1. Okay, so let's move forward to the next one. There are 2 more left. So the integral of sine x over 2 minus cos x, that's not standard form. I can't change it using trigonometry easily. I cannot use integration by parts because there are not 2 separate class of functions. So I can solve this either using a quick way, reverse chain rule, or I could just make u as the bottom if I would like to insist to use integration by substitution, so u will be 2 minus cos x, and then you could solve it that way. And if you want to use integration by substitute, if you would like to use reverse chain rule, the quicker method, then this is f of x. And when you differentiate my one in brown, so you will get just sin x. That is the format that we have, and that will lead us to use ln of 2 minus cos x plus c, and that will be the answer. And now just the final one, the integral of x plus 3 cubed. It's not a standard result. It's not it cannot be rewritten in any format. It's not two different class of functions. And so if I start by thinking of integration by substitution, u will be inside the power bracket, which is x plus 3. So you could solve the integral from there. So as a wrap up, so you will notice that later on when we do applications starting from 11.8 area under the curve, solving differential equations, so to speak, the integrals will be all mashed up. So they will be all in different formats, and you need to quickly recognize which way to solve it. And that is my take, where you could start from the fundamental results catered with f of x plus b to start approaching those integrals, and then step by step to decide which way to use. So integration by substitution is a substitution always for reverse chain rule. So you could use it. However, reverse chain rule is quicker for some cases. And there will be another reminder that there will be questions where you could only use integration by substitution, but not reverse chain rule. Okay, so that is all I would like to discuss with you as a wrap up, as a review from 11.1 to 11.7. So thank you, and I'll see you guys the next time.